We are going to look at box plots. This video is split into 8 parts. In part 1, we are going to look at, well, how do you read data from a drawn box plot? Part 2, we're going to look at, well, how do you plot data into a box plot? And then we're going to look at, well, how do you use raw data and convert that into a box plot? And then we're going to look at answering percentage and percentile related questions on box plots. And then look at drawing percentile related questions on a box plot. And then look at slightly more worded questions around problem solving. And then finally, we're going to look at, well, how do you compare two distributions? And that should cover everything you need to know for your exam on box plot. So the way my videos work, I'm going to do the example on the left, then you're going to press pause and have a go at the example on the right. So starting with the one on the left, the minimum value is that one there. In a box plot, the maximum is that one there. So if I start writing that down, so the minimum is at 10, the maximum is at 44. Now the median is this value in the middle right there. So that is going to be 25. The lower quartile is that right there, which is 19. The upper quartile is 32, and that is that right there. And then finally, the interquartile range is just the upper quartile take away the lower quartile. So that's just 32, take away 19, which is 13. And the range is the biggest, so the maximum take away the minimum, so that's 44 take away 10, which is 34. Now press pause and have a go at the example on the right. So the minimum, so again, you want to be careful with the scale here. It's not going up in ones, so that's going to be a 6 right there. The maximum is right there, and that is at 24. The median is this value right here, and that is at 11, 12, 13, 14. The lower quartile is at 11, which is that right there, and the upper quartile is at 17. Now the interquartile range is just the case of subtracting these two, so that's going to give us a 6. And the range is just a case of subtracting 6 from 24, and that gives us 18. So now we're going to look at the opposite, so we're going to draw on a box plot. So start off, I'll work from top to bottom. So minimum is 15, so that's right there. There's no sort of rules on how long the length should be, but I normally tend to keep it one full square. The maximum is at 50. The median is at 30. The lower quartile is at 26. The upper quartile is at 45. And now if I connect the lower quartile and the upper quartile together, like so, and then finally connect this to the end and connect this to this end. And that is how you draw a box plot. So press pause and have a go at the example on the right. So grab yourself a pen and a piece of paper. So the minimum is at 10. The maximum is at 52. In fact, I'll zoom in a little bit just so I can be precise. Median 36. Lower quartile 30. Upper quartile 40. And if I connect that together, and connect that together, and if I connect that together there, and that together there, again, you'll be using a pencil and a ruler to do this, so your lines should be straight. Mine one is a little bit bent, but yeah, you should get something like that. So now this one's a little bit different, although it might look the same. So notice you haven't been given the minimum here, but you've been given the maximum. So let's just start off with what we can. So let's start off by looking at the maximum. So the maximum is at 55. Let's start off with what we can plot. So that's that done. The median is at 30. That's that done. The lower quartile is at 25. And that is that done. So now we're left with the range and the interquartile range. So now if I look at the range first, now you know the minimum take away the maximum gives you the range. So if I do the range take away the maximum, that gives me 5. So that means the minimum must be 5. And you can check that because you can do 5 take away 55, and that gives you 50 as a range. So that's that ticked off. So the lower quartile, sorry, the minimum value is 5. And then now we can use the interquartile range to get the upper quartile. So I'm just going to add these two together. That gives me 35. I'm going to plot that there. Okay, so we just had to do a bit of calculation before plotting this because we weren't giving 2 bits of information immediately. But yeah, so that we can do that there. So again, hopefully you've pressed pause and now got the example on the right. So the median gives you 70. I always tend to plot the data where I can, so I've just started with the median. The maximum is at 100. the lower quartile is at 50. And I think that's about all I can immediately plot. Now, with the range, we can work out the minimum. So the minimum here is going to be 100, take away 60. That's 40. That's that done as well. And then we're left with the interquartile range. So because we have the lower quartile, we can just add these two together. And that'll give me the upper quartile. So 50 plus 30 is 80. And that is that. And just connect these together. Again, you'll be using a ruler and a pencil to do this nicely with straight lines. So here's some practice questions for you to have a go at. Press pause and have a go. Here are the answers. Mark your work. So moving on. So how do you find the median of a set of data here? So I've purposefully included a slide in here because some people can find this a bit confusing. So I'm just going to change my pen color for a second. So the median is the middle number. So in this case, we have 5 numbers and the middle of the 5 is that one there. How do I know it's the middle? Because each side has the same amount of numbers. So this side has 2. And this side has 2. Okay, so that's how you know something's in the middle. It'll have the same amount of numbers on the side. So what I circle here, this is the median. And now the lower quartile is the middle of what's left. So what's left on the left side are 2 values here. What's the middle of these 2? So now the middle of these 2 values is whatever's right there. So that's going to be 15. And if I do the same on the right, what's in the middle of these 2 values? That's going to be 45. And the way you can do that is you can do 40 plus 50, divide that by 2. Sometimes it's not immediately obvious. So this is the upper quartile and this is the lower quartile. So if we move on to the next one, the middle value here is 40 because there's then 3 on the left and 3 on the right. So if I circle that, that's my median. I'm now left with 3 values on the right and 3 values on the left. Now the middle of these 2 is going to be 60 in this case. And the middle of these 2 in this case is 20. Okay, remember, how do you know it's the middle? Because it'll have the same number of values on the left and the right of it. Okay, so this has 1 on the left and 1 on the right. Moving on. Now with this one, the middle is 50 because you have 4 and 4 on each side. So that's your median. And now to find your upper quartile, so that's going to be the middle of what's left over. So the middle of what's left over here is whatever's in the middle there, so that's 75. And the same here, the lower quartile is the middle of whatever's left over on the left. So that's going to be 25 here. Now it gets a bit more, I wouldn't use the word tricky. It just isn't very obvious when it's even numbers. So with even numbers, like the next example, well, the middle is actually right there. Because remember what I said with the middle, you should have the same number of digits left on the right and the left. So when the middle is there, that is 35. And it's the middle because we're then left with 3 values on this side and 3 on this side. And now if I look at what's left over, that's this here. So the upper quartile is 50, and the lower quartile is the middle of these, and that's 20. And then finally looking at these, so the median is what's in the middle there. The lower quartile is what's in the middle of what's left over, so that's 25. And then the upper quartile is the middle of what's left over on the right, and that is 65. Now press pause and have a go at the example on the right. When you're ready, press play for the answers. So the first one, nice and straightforward. The median is 15. Now the upper quartile is whatever's left over on the right. So the middle of it, so the middle of these 2, that's 22.5. Again, you can do 20 plus 25, divide that by 2, okay? And then the lower quartile here is going to be 7.5. Moving on, for the next one, the middle is what's in the middle here. So that's 17.5 for the median. And then what's left over, we find the middle of that, and that is the lower quartile. And what's left over on this side, the middle of that is 25. That's the upper quartile. With the next one, the median is 20. The lower quartile is 10. The upper quartile is 30. And the last one, the median is right in the middle. So that is 22.5. And then the lower quartile is the middle of what's left over. So that's 12.5. And the upper quartile is the middle of what's left over. And that's 32.5. So the reason we did that is because sometimes you get questions like this. So in a case like this, let's start filling it in. So the minimum value is 10, the maximum value is 20. No, not 20, 60. The median is the middle. So in this case, the middle is going to be 35. The lower quartile is the middle of what's left over. So that's going to be 20. And then the middle of what's left over on the right is the upper quartile, so that's 50. So if I plot these, so the minimum is 10, the maximum is at 60. median is at 35, lower quartile is at 20, upper quartile is at 50. There. And if I connect them together, and there we have it. So press pause and have a quick example on that, right? So now with this one, the minimum is 5, maximum is 28. Another thing I should add here is the data does need to be in order. So all these numbers have been written in order. Sometimes they're not written in order, so you will need to put them in order first. The middle is right there, so that's the midpoint of 10 plus 14, which is 24, so that's 12. And I divide it by 2. The lower quartile is whatever's left over. The middle of it, so that's 8. And the upper quartile is the middle of whatever's left over, so that's 15. If I plot that, so that is a 5 there. 26, 27, 28. That is right there. And then we have the median at 12, so that's 11, 12. So just careful with reading these axes, so I'll just do that a little bit. The lower quartile is at 8, so that's going to be that right there. The upper quartile is at 15, so that's going to be that right there. And then finally just connect all of that together. And there we have it. So here's some practice questions for you to have a go at. Press pause and have a go. Here are the answers. And now moving on. So it's now looking at percentages. Percentile, sorry. So the box plot shows test score data. What percentage represents a score under 27? So if you look at the box plot, where is 27 on the box plot? Well, 27 is right there. What do you know about that point? That is the median. Okay, and the median represents half the data. So in this case, that is going to be 50%. If you look at the next one, well, where is 32? 32 is the upper quartile. So the upper quartile represents 75% of the data. What about over 32? So, well, if under 32 is 75%, then over 32 must be 25%, okay? Because percentages add up to 100. And then what about under 17? So under 17 is going to be from here down. So that's below the lower quartile, and then the lower quartile represents 25% of the data. So press pause and have a go at the example on the right. So under 21, where is 21? 21 is right there. That's the median. Remember, the median represents 50% of the data. It is an average. Now under 25, 25 is the upper quartile. So that's going to be 75% of the data. Over 25, so that is going to be whatever's left over. So that's 25%. And over 17, now 17 is the lower quartile. Okay, so over 17 is going to be 75% here, okay? Under 17 is going to be 25%. So that is 75% of the data. So what's key to remember here really is just remember the median is 50%, okay? The lower quartile is your 25%, and your upper quartile is your 75%, sort of all facing to the left. So when the question does say how many are over 17, we then sort of look that way, and that's why this was 75 and not 25. So now we're basically given percentages, and we're asked to plot, draw box plot using them. So 25% were 26 years old. So 25%, that's lower quartile. We plot 26 on. 50% was 38, so that's the median. 75% were 45, so that's the upper quartile. The oldest was 56. And the youngest was 21. Now connect all of that together. Again, you will be using a pencil and a ruler to do this. So that gives you that. Yep, again, press pause, and I've got the example on the right. So 25% were under 30 kg. So that's your lower quartile. 50% were under 45. That's your median. And then 50% were under 38 is your median. So that's there. The lowest was 10. The heaviest was 52. So here's more of a worded question. So the first one says, well, we've got heights of 20 plants, draw the box plot. So let's just draw the box plot. So the minimum is 5, the maximum is 25, the median is 15, 16, 17, it is there. And then we have the lower quartile at 10, and we have the upper quartile at 20. And if I just connect all of that together, that is part 1 of the question done, which says draw the box plot. So that is that done. Now the next one says, Andrew says 3/4 of the plant height lie between 10 and 20. So where is 10? 10 is there. Where's 20? 20 is there. Now we know that this is the lower quartile and this is the upper quartile. And in between this, that holds 50% of the data. So that is why he is wrong. And you would just write, explain why he is wrong. 10 to 20 centimeters represents 50% of plant height. And it says work out an estimate for the number of plants between 5 and 10 centimeters. So if you look at where 5 and 10 is, that's there. So that's everything below the lower quartile. We know the lower quartile is 25%. So that represents 25% of the plants. So how many plants are there? We're told in the question there's 20 plants. So 25% of 20 is equal to 5. So the answer to this question is 5. And it says what percentage of plants had a height of 17 centimeters? So 17 centimeters is the median. The median represents 50%. So that is going to be 50% right there. So again, hopefully you press pause and had a go at the example on the right. So drawing the box plot at 133 is there. 170 is there. 151 is there. 146 is there. Upper quartile 157 is there. So work out an estimate for the number of girls with a height between 133 and 157. So I can see that 133 is there and 157 is there, and that's from there to there. That is the upper quartile. So that means everything below that point is going to be 75%. So that is going to be 75% of how many girls are there? 80, we are told. So that is going to be 60. And it says work out an estimate for the number of girls with a height between 133 and 146, which is the low quartile. Now, everything below the low quartile represents 25% of the data. So that means this is going to be 25% of 80, and that is 20. So finally, the type of questions you get asked are also to compare distributions. Now, the way you want to compare distributions is using the median and the interquartile range. Now, the mark scheme specifically does ask to compare the two. So the way I'd like to compare this with maths, so say we've got maths and science course, so we would say the median math score, and of course you would write what the median is, so in this case is 25, is less than median science score, which is 28, and you would write an exact same statement for the interquartile range, and then you would say the interquartile range for the math score is 11, and which is less than, so you're comparing the data, science, which has 16. Okay, you want to be specific with your numbers and you want to be specific with your comparison. You want to say whether it's greater than or less than, and then you also want to say what the digits are. So again, with this one, did come up on an exam. So you're comparing the weight of potatoes for Amy and Tom. So you would say the median weight, I'm just going to write this in short form. So the median weight of potatoes for Amy is 42. It isn't 42. What am I doing? It is the number right there, which is 57, sorry. It's 57 kg, which is greater than Tom's 42 kg. And then you do the exact same statement with the interquartile range. So we would then just write down the interquartile range for Amy, and you can see that by the graph it's going to be higher, is 26, which is, again, you don't just want to say it's 26, you want to say it's 26, which is greater than Tom's is 16 kg. Okay, so don't just list the numbers. You don't get any marks for listing the numbers. You have to be specific and you have to make a comparison. So here are some practice questions for you to have a go at. Press pause and have a go. When you're ready, press play for the answers. Here are the answers. Mark your work. If you find that video useful, please consider subscribing. And as always, I'll catch you in the next one.